Good evening. It is a pleasure to welcome all of you to the lecture of the winner of the third Calvó-Armengol International Prize, Professor Raj Chetty. Congratulations, Professor Chetty, and thank you so much for being here with us today. I want to give a warm welcome to Tony's family and friends, and especially to his wife, sons, and his sister, who are this evening with us. The Calvó-Armengol Prize was created to honor the memory of our colleague and friend, Antoni Calvó-Armengol, professor at the Universitat Autònoma de Barcelona and one of the most promising academics of the Barcelona Graduate School of Economics, and also one of the best scientists in Andorra's history. The three institutions that promote this initiative designed an award to recognize international renowned, young, and promising social scientists like Tony was. The winners of the three editions, Esther Duflo, Roland Fryer, and this year, Professor Raj Chetty, share with Tony initiative, ideas, academic rigor, excellence, and social commitment and involvement, qualities that we would like to recognize and we would like to preserve with this prize. I want to thank the Govern d'Andorra and Fundació Crèdit Andorrà, their presence here today, and their involvement in sharing the goals, profile, and commitment of the prize. We are together in making sure that this prize consolidates and becomes a reference in the international academic community. I would also like to thank the work of the award jury, chaired by Professor Matthew Jackson, and composed also by Professor Salvador Barberà and Professor Joel Sobel. The quality of the winners selected in the three editions and its harmony with the values of excellence and commitment that we want to stand for prove the excellent work of the jury. I would also like to thank the work of our Deputy Director for Research of the Barcelona GSE, Nasi Gunner, who has coordinated the award on this third edition, and of those who have worked to make possible the official ceremony in Andorra yesterday, the academic workshop in Barcelona that started this morning, and this academic lecture. We're grateful to Fundació Catalunya La Pedrera for hosting the Calvó-Armengol lecture in this wonderful landmark, La Pedrera. There couldn't be, I think, a better place in Barcelona to honor the memory of Tony. Salvador Barberà, professor at Universitat Autònoma de Barcelona and also research professor at the Barcelona GSE, will present Professor Chetty.
Hi, it's my very pleasurable job today to introduce our speaker, Professor Raj Chetty of Harvard University, the third recipient of the Calvó Prize, instituted in honor of the memory of Tony Calvó. I am, so to speak, the local member of the committee that proposed his name to the Barcelona GSE for the Calvó Prize. And hence, let me start, as already Teresa did, by thanking the other two committee members, Joel Sobel from the University of California, San Diego, and Matthew Jackson from Stanford University, for their continued support to this initiative. Working with them is a privilege. They are friends who care about Tony's memory. They make all efforts to identify those amongst the best candidates who, in addition, stand for the type of economic and social concerns that Tony cultivated. And every time that we communicate, I learn very much from them. They follow the rise of new stars in the profession from the highest vantage points and with the most demanding standards of judgment. When I go to the Louvre or to the British Museum, I always spend some time visiting the exhibits of Mesopotamian tablets in cuneiform writing. I am admirative of these pieces, where you can find, among other gems, textbooks and class notes of geometry with their neat graphical representations that witness to the genius of ancient cultures. And one of the things that impresses me most when admiring these tablets is to think that their initial purpose was to collect data about wealth and production. Its immediate application was the collection of taxes, and its secondary result was the rise of phenomena like smuggling and tax fraud. Very old and very present concerns indeed. Thousands of years later, administrations still collect massive data on production and taxation, and we have a long tradition of scholarship around topics relating to public finance. It is amazing that in the early part of his career, Professor Chetty was able to emerge as a very unique and innovative contributor to this vast body of knowledge. He combined standard data obtained from many sources with other information that he derived from research purposes through experiments that he created with a view to the economic analysis of taxpayers' behavior. He worked with massive amounts of data, both existing and newly created, managing to shed new light into different aspects of that behavior, thanks to his ability in posing new questions and using imaginative variants of theory and econometric techniques. If it is always impressive to find people who emerge from the crowd and are able to open new ways of thinking, it is even more so when the topic has such deep roots in human history. Important as taxation issues may be, I want to emphasize that Raj Chetty has gone on to cultivate many other fields of public economics, where he continues to break ground. You may look at the impressive list of recognitions and of responsibilities that he has already accumulated in these first years of his academic career, and that can only make you wonder about what comes next. One of the reasons for this, undoubtedly, is that he looks at central issues that people recognize as such and is able to shed new light on them. His presentation today is in the line of his recent work on concerns that are at the very root of our democratic values: the opportunities for young people to improve their lot relative to their parents, and the role of education, of educators, and of the social environment in creating conditions for a country to become a land of opportunity. I'm sure that his lecture will open our eyes to hard facts regarding upward mobility, its measurement, and the obstacles that it finds under different cultural and social settings. One thing that is common in much of the literature today and very worth emphasizing is the crucial role of education, and especially of very early education, for the lifetime performance of individuals. But there is more, and we are here to learn from Professor Chetty about these and other factors that generate or prevent the rise of equal opportunities through his lecture on the value added of neighborhoods, neighborhood effects, and social mobility. It will be our task to learn about universal facts, facts from other cultures, but also later on to translate this learning into lessons for our own society, our own educational system, and our social structures. These were indeed concerns that, again, as Teresa said, Tony had along his life, and his interest on social issues was very keen. Therefore, we thank Professor Chetty in advance for what we learned from him, but also very especially for embodying once again, as did the previous recipients of the prize, the blend of intellectual excellence and social concern that we want to celebrate with that prize. So thank you, Raj, and the floor is yours.
So thank you very much. I'm truly honored to receive this award and join the list of previous recipients. And I'm especially honored to receive an award in the name of Tony Calvó-Armengol, I think today's excellent conference, where we have an outstanding set of presenters who I'm very grateful could be here, illustrated for me in two ways how Tony's work continues to influence all of us. The first is his interest in the impacts of social networks and social effects and economic outcomes was reflected in a number of the papers that were presented, where people are continuing to refine the theories he developed and apply them to empirical analysis of important questions. The second, coming back to a theme that was just mentioned, is I think one of the priorities for Tony was doing work that has great public policy relevance and making economics understandable to the public and have a broader impact, something that I'm also very passionate about. And I'm hopeful that we can continue in that path with the many of us who are here continuing in his tradition. So I think if Tony were here, he'd be very proud to see the workshop and the work that's being done in the field that he helped create. So today I'd like to talk about a topic that's, again, I think very highly policy relevant and is on the minds of many people across the world, which is thinking about the determinants of social mobility. There's a long-standing academic and policy interest in this subject, and the very simple question of how we can improve disadvantaged children's chances of moving up in the income distribution. And in particular, the angle that I'm going to focus on in this lecture is to ask whether social mobility is determined primarily by forces such as genetics, for example, things that are very difficult to change, or can they be influenced significantly by changes in environment? And if so, what can we possibly do to improve children's chances of success through changes in policy, for instance? Now, this is a very old question that has deep historical roots, and there's a vast literature that has analyzed both the issue of social mobility and the role of neighborhoods in social mobility and other economic outcomes. But my perspective is that the answers are still debated, partly due to limitations in data. And so with the advent of modern large data sets, we can obtain new and hopefully insightful answers into some of these long-standing questions. So in these two literatures, as some of you know, there's a debate even about the measurement of mobility, the degree of mobility in the United States and in other countries. What exactly is it? How has it changed over time? How mobile are our societies? And in the context of neighborhood effects, there's a debate about whether neighborhoods and environments actually matter for children's outcomes. Sociologists would say quite strongly that there's a lot of evidence that children growing up in poorer neighborhoods or neighborhoods with worse schools or different amounts of segregation have very different outcomes from kids growing up in better areas. But economists don't necessarily agree with that viewpoint based on some of the best work that's been done to date. For example, the very influential Moving to Opportunity experiment, which in some sense is the gold standard in this literature, where we tried to randomly move families with their children to better neighborhoods and actually ended up finding that there was not much of an impact on children's economic outcomes. So you have these two very strongly competing views, and I'm going to try to shed some light on how we might reconcile that conflicting evidence and how all this ties together into social mobility. So the way we're going to do that is by studying intergenerational mobility within the United States primarily, although I'll provide some cross-country comparisons, using administrative data from a vast new database where we're able to study 40 million children and their parents. And I'm going to show you results from a series of papers we're working on this topic, the first of which is joint with Nathan Hendren at Harvard and Pat Klein and Emmanuel Saez at UC Berkeley. And in that first paper, we find that there's the main result is that there's substantial variation in intergenerational mobility within small communities within the United States. So the way to think about the US, sometimes characterized as a land of opportunity, is rather that there are some places in the US that look like lands of opportunity, and there are other places that are better described as lands of persistent inequality, where if you happen to be born to a poor family, you do not have very good chances of escaping poverty. Now, in the second paper, I'm going to follow up on that and this work that I'm doing with Nathan, which I'm going to present some initial results from. We show that much of that variation across areas that we document in the first study is actually due to the causal effect of neighborhoods, that we think this is an environmental effect, and not merely the fact that different people live in different places. And as a result, I view this as a very encouraging sign, in that it suggests that the degree of social mobility could potentially be improved substantially by changes in environment and possibly by suitable changes in policy. So let me give you an outline of the talk. I'm first going to show you some national statistics on what intergenerational mobility looks like. And then I will turn to the first set of main results, which are on geographical variation in mobility across areas within the US. I'll then turn to the second paper on the causal effects of neighborhoods and show you why we think those differences across neighborhoods are actually driven by the causal impacts of living in those different places. And finally, I'll conclude by briefly describing some work we've done to try to identify what's different about the areas that deliver good outcomes for low-income children, high rates of upward mobility versus areas that do not, which may point the road towards the types of interventions we can implement both in the US and in Spain in terms of improving upward mobility. So let's start with the national statistics. Let me tell you first a little bit about the data and be precise about how we're going to measure things. So the data we're drawing on is a panel data set that we've constructed from raw tax returns with important work done by one of the presenters here at the conference, Danny Yegan, who's at UC Berkeley, where we've essentially constructed an 8 billion row panel data set covering the United States population, which gives you de-identified data from 1996 to 2012 income tax returns. And importantly, one thing I want to emphasize for the purpose of this talk is that you normally think of tax data covering people who file tax returns, but it also includes everyone who does not file a tax return because we automatically see their incomes reported to the IRS from their employer. So there are information returns that allow you to cover people, even those who do not file tax returns themselves. And that's very important when studying social mobility, particularly at the low end of the income distribution because people may not file taxes. Now, this data set gives us information on a variety of outcomes beyond what you'd expect to be in a data set on tax returns, like income measures. And that's basically one of the few virtues of having an incredibly complicated tax system. It's that the government collects a great deal of data on all kinds of things, and so we know where everybody in the US is going to college, and we can develop measures of teenage birth and various other outcomes that I'll describe in this talk. Now, we take that large data set, and for the purposes of this paper, we're going to focus on a subset of children. The primary sample we're going to analyze are US citizens in the 1980 to 82 birth cohorts. So all children born in the US between 1980 and 82. That's about 10 million children who are going to be between the ages of 30 and 32 in 2012, which is when we're going to measure their income as adults. And I emphasize their age in 2012 because you need to look at people who are sufficiently old in order to measure permanent income, right? So you can't measure people's income when they're 20 years old or 22 years old because a lot of the highest achieving kids in terms of permanent income are going to be in college at that time. And so we basically think this is sufficiently old that you're able to get a sense of permanent income in the early 30s. And then I'm also going to use, for some parts of the analysis, an extended sample that covers the 1980 to 1991 birth cohorts. That's about 40 million children. And what we do is we take these children and we link them to their parents based on dependent claiming. So in the US, parents claim tax credits and exemptions for children, and the way they do that is by writing their Social Security number on tax forms, which you can then use to link the children back to their parents, which permits the analysis of social mobility. Okay, so just to be precise, let me tell you a little bit about how we measure income. So we measure parent income as mean pre-tax household income over a 5-year period from 1996 to 2000, when the kids are approximately 15 years old. And then we measure child income as mean pre-tax household income between 2011 and 12, when they're roughly 31 years old. Now, I'm not going to get into the details in this talk, but we show in our paper that the results are robust to using a variety of alternative income definitions. So for instance, you might think about measuring at the income at the individual level rather than the household level. Or you might think of measuring child income at later ages beyond age 30, and you end up finding similar results where we have smaller random samples. Or you might think of using longer time averages, not just 5 years, but many more years. And again, you get very similar results to the ones that I'm going to show you here. Now, the study of social mobility and intergenerational income mobility fundamentally is basically about characterizing the joint distribution of parent and child income. there are many ways in which you might think about characterizing a joint distribution, right? There are many statistics that you can use to characterize a joint distribution. We are going to focus in particular on a rank specification. So we're going to characterize mobility by studying people's ranks in the income distribution. And so the way we do that is very straightforward. We take all the children born in a birth cohort, so say all the approximately 3.5 million children who were born in 1980 in the United States. We order them from 1 to 3.5 million on the basis of their incomes at age 32, and we convert that to percentile ranks. And then we do the same thing for parents, and we rank parents relative to other parents of children in the sample, again, converting to percentile units. So here's the first look at the data. Social mobility in the United States. What this figure plots is children's percentile ranks in the income distribution versus parents' percentile ranks. So the initial way you might think about looking at a data set like this is just doing a raw scatter plot, right? So if you did a scatter plot with 10 million points, you'd see a giant blur and you wouldn't really be able to discern the key patterns. So what we've done in this figure is it's a binned scatter plot. We divide the x-axis into 100 equal sized bins, percentiles, and we're plotting the mean of the child's income rank within each of those bins, right? So the x-axis is the parent's income rank going from 0 to 100, and then the y-axis is the average child income rank within each of those bins. So it's the conditional expectation of the child's income rank given the parent's income rank. And you can see, first of all, as is well known from prior work, there's a very strong upward sloping relationship. If you're born to a richer family in the US, you yourself as a child are richer. If you're born to families in the top 1%, you reach roughly the 66th or nearly the 70th percentile of the income distribution. If, on the other hand, you're born to a family in the bottom 1%, you reach roughly the 30th or 35th percentile of the income distribution. So roughly a 34 percentile gap between the bottom and the top for people in the US. Now, is that a big gap? Is that a small gap? I think it's difficult to have intuition about that without having comparisons to other societies, to other economies, and so forth. And so we very helpfully got our friends in Denmark to replicate exactly the same analysis in Denmark using the same income definitions, same birth cohorts, and so forth. And this series in triangles shows you the same data for Denmark. And you can see that in Denmark, the relationship is much flatter, right? In fact, the slope is almost half that in the US. That is, the parents to whom you're born in Denmark, at least in a percentile rank sense, matter much less than they do in the US. Now, we don't have data sets like this for every country that you might be interested in studying, but there are other estimates from other types of survey data, which are a little bit more limited in terms of what you can do, but people have tried to estimate intergenerational earnings elasticities, essentially the correlation between parent and child income. And here I'm drawing on work from Miles Korak, who's compiled estimates from various studies and tried to make things comparable. And this plots the estimates for various developed countries. And what you can see here, as you go to the right, you have lower correlations between parent and child income, so more intergenerational mobility, a flatter slope in the context of the graph that I was just showing you. And consistent with the data that I was showing you before on the previous slide, Denmark is one of the countries with the very highest levels of social mobility. And on the other end of the spectrum, you have places like the UK and the US. Spain, given the data that we have, which is more limited, considerably more limited than the data available in other countries. And I think that actually, from a policy point of view, would be very useful in Spain to try to develop the type of administrative data that are available in other countries. But given the data that are available, it looks like Spain is roughly in the middle of this distribution, actually maybe a little bit more mobility than the US or the UK. Now, another intuitive statistic that the public often finds interesting is a very simple measure of success, what you might think of as the American dream. So think about the probability that a child born to parents in the bottom fifth of the income distribution rises to the top fifth of the income distribution. So just a very simple measure of kind of moving from rags to riches, what fraction of children achieve this. So in the United States, in our data, that probability is 7.5%. In Denmark, it's 11.7%. And in Canada, it's 13.4%. Now, some people react to this by saying, oh, even in Canada, the probability of succeeding isn't that high, right? Well, you have to remember that unfortunately, you can't have more than 20% of people in the top 20%, right? So the maximum on that number is 20%. And so, the way I interpret this is that in some sense, your chance of achieving the so-called American dream are 1.8 times higher if you're in Canada rather than in the United States. And so that's quite a substantial difference, right? Nearly a factor of 2 difference in your probability of upward mobility. And so while those cross-country comparisons I think are really motivating, what I'm actually going to show you is that there's even larger variation in rates of upward mobility within the United States. So you see greater variation than the types of statistics that I've been showing you across countries. So let's turn to that next. So in order to study geographical variation, we first need to talk about how we're going to define areas in the US. And so what we do is we study intergenerational mobility at the level of what are called commuting zones. So we partition the US into 741 areas, which are similar to metro areas, but they give us a complete partition in the sense that they cover all rural areas as well. And basically what these commuting zones are aggregations of counties based on commuting patterns. So we group places where people seem to be commuting within that area and call that one, like the Boston metro area or the New York metro area, et cetera, right? So we then take that geographical classification and we divide children into locations based on where they grew up. So technically the way we define this is the commuting zone from which the parents filed a tax return when they first claimed the child as a dependent on tax forms. Now, very importantly for the results I'm going to show you, we permanently assign children to that commuting zone regardless of where they live afterward. So children in the US move around a lot, and in particular one pattern that I'll show you is that there are many rural parts of the US where kids seem to be doing extremely well in terms of upward mobility, but those children are no longer living in those rural areas when we're measuring their incomes as adults. They've moved to New York or they've moved to San Francisco and so forth. So whenever I refer to location in this talk, I mean where the children grew up and not where they're living as adults. Okay, so in every commuting zone, we measure parent and children's incomes using ranks in the national income distribution. So this is very important, as you'll see, because it's going to allow us to measure 2 different concepts of mobility at the local level. One that I'll call relative mobility, similar to the measures that I've been showing you, the slope of these relationships, and another that I'll call absolute mobility, which I actually think might be of greater normative interest. So just to be clear, we are ranking everybody in the national income distribution, and so if you grew up, for instance, in Boston, you're not being ranked relative to other people in Boston, you're being ranked relative to the US distribution as a whole. So let's now turn to what geographical variation looks like by starting with a specific example. The Salt Lake City, Utah metro area. And this figure here replicates the figure that we started out with, the national rank-rank relationship, but subsets the data to the children who grew up in the Salt Lake City metro area. So one way you can think about measuring the degree of mobility, which is exactly what we started out with at the national level, is what I'm going to call relative mobility. What are the outcomes of children from low versus high income families? And so a simple measure of that, exploiting the fact that this relationship looks highly linear, which is actually a very convenient simplification, we find in all of our analysis that these rank-rank relationships always look remarkably linear. That means that we can characterize the conditional expectation function just using the slope and the intercept. So the measure of relative mobility then, one way you can define it is the gap in outcomes between kids from the richest family in Salt Lake City, what I call Y100, minus the outcomes for kids from the poorest family in Salt Lake City, what I call Y0. And that's, of course, just 100 times the rank-rank slope. In Salt Lake City, that number is 26.4, meaning that there's a 26.4 percentile gap between the bottom and the top. Remember that in the US as a whole, that number was roughly 34 percentiles, right? That was the slope we started out with. Now let's compare Salt Lake City to another city in the US, Charlotte, North Carolina, where we conduct exactly the same analysis, but in Charlotte, this rank-rank relationship is much, much steeper, right? And the gap between the bottom and the top is 40 percentiles rather than 26 percentiles. So there's a much less social mobility in this relative mobility definition. Now, another way in which you can think about defining mobility is absolute mobility. What are the outcomes of children whose parents' income rank is a given level P? So for example, you might think about the expected child rank of parents at the very bottom of the income distribution. Where can you expect to reach on average if you're born to the lowest income families? More generally, you can think about the expected rank at any given percentile P, and again, given linearity, that's just going to be the intercept, y0, plus the slope times the percentile P that you're interested in. Now, a convenient property of the linearity of the rank-rank relationship is that expected outcomes for all children can be summarized just by estimating the slope and the intercept in every commuting zone, and so that's what we're going to end up doing. Now, I'm going to focus for concreteness on outcomes at one particular percentile, the 25th percentile of the income distribution, and again, given linearity, the expected outcome at the 25th percentile is going to be the same thing as the expected child rank, given that you have parents below the median, all right? So it's just a simple way of thinking about what are the average outcomes of children from low-income families. And I'm going to call that absolute upward mobility as a shorthand, and this is going to be one of the main statistics that we focus on. Now, in Salt Lake City, the level of absolute upward mobility is 46.2. So what that means is children growing up at the 25th percentile of the income distribution in Salt Lake City reach the 46th percentile on average. So just on the face of it, you can see that that's a substantial amount of upward mobility, right? In the sense that you're growing up in a pretty low-income family, but on average, you're getting pretty close to the US median. So if you compare and contrast Charlotte, North Carolina, there, the level of absolute upward mobility is only 35.8. And to give you a rough sense of magnitudes here, the 46th percentile of the US income distribution when kids are about 30 years old is $31,000, and the 35th percentile is about $23,000. So if you imagine for a moment that there's some way we could make Charlotte look like Salt Lake City, maybe some policies we can change, you would have a tremendous effect on the lives of low-income children and on the aggregate economy if you could increase children's incomes by something on the order of, 30, 40%, something like that. Now, one interesting property of the Salt Lake City versus Charlotte comparison is that you see a convergence at the top, right? So location matters much more for low-income families rather than high-income families. If you're from a family in the top 1%, it actually doesn't make very much difference if you're in Salt Lake City or Charlotte. And that's maybe intuitive, that rich people are able to insulate themselves from local conditions, for instance, by sending their kids to private schools and not having to use the local public schools. And that turns out, you see that comparison in this particular pair. More generically, it's not always this stark that one place completely dominates another, but what we find is that this relationship tends to pivot relatively high, meaning that places with more relative mobility, that is a flatter slope, tend to have better outcomes for children from poor families rather than worse outcomes for children from rich families. And that's why, coming back to what I was saying earlier, the distinction between relative mobility and absolute mobility I think is quite important, because it's not clear that a flatter slope in what I was showing you initially with the cross-country comparisons is necessarily a good thing. Meaning a lower intergenerational correlation doesn't necessarily mean that it's low-income kids doing better. It could rather be high-income kids doing worse, right? So you shouldn't necessarily be interested in the intergenerational correlation or measures of relative mobility from a normative point of view. However, these measures of absolute mobility, how well are kids from low-income families doing in absolute terms, I think everyone can agree that if we improve absolute mobility at the bottom, in dollar terms we get low-income children to do better, that's better for them and that's better for the economy as a whole. And so that's why I'm going to focus primarily on the absolute mobility measure in the remainder of the talk. Okay, so let's now generalize from the two examples that I've given you and look at the entire US. So what we do is compute the measure of absolute upward mobility that I just discussed, the mean outcomes for children at the 25th percentile for every commuting zone in the United States, and we put that on this heat map. So the way this map is constructed is we compute the statistic for every area, and we divide the area into 10 deciles shown by the legend on the right, and we color the areas based on their level of upward mobility. So lighter areas are areas with higher levels of upward mobility where kids from lower income families are doing better. So if you look at areas in the top decile, the lightest colors in this map, children in those areas are starting out at the 25th percentile, but they're crossing the US median on average. They're crossing the 52nd percentile on average. So it's actually a remarkable amount of upward mobility in those places. At the other end of the spectrum, in the darkest red areas, kids who are starting out at the 25th percentile get to less than the 37th percentile on average. So really a vast gap in levels of upward mobility across these different places. Now there's a lot of data on this map, and it's publicly posted, so those who are interested can explore it further. But let me just summarize what we see as some of the broad patterns. So the first thing you see is that there's, of course, very broad regional variation, right? So the southeastern United States has much lower levels of upward mobility than the rest of the country. But while your eye is drawn to that regional variation initially, there's also a lot of local variation. In fact, 45% of the variance in this map is within states. Something like 60% of the variance is within regions. So to take one example, let me draw your eye to the northeastern United States and look at Ohio versus Pennsylvania. Ohio here and Pennsylvania here, relatively close to each other. These two states are states that we generally think of as being pretty similar in terms of economic structure and demographics, yet Ohio looks considerably worse in terms of upward mobility than Pennsylvania. So it's interesting to try to understand why is there such a big difference between what we would have thought of initially as being relatively similar places. Another generic pattern that you see, it's a little bit hard to pick out on this map. Let me draw your eye to some examples. If you look at Chicago here, the upper right corner of Illinois, versus the rest of rural Illinois or rural Iowa, you see that the rural areas in the US tend to be much lighter colored. They tend to have much higher levels of upward mobility than the urban areas. And here you have to remember the point that I was emphasizing before. These are the locations where the children grow up and not where they're living as adults. A lot of the kids who are very successful in Iowa end up moving out as adults. And so what makes Iowa and the rural Midwest particularly remarkable, I think, from the perspective of social mobility, is that they have kind of a brain drain effect where they create really good outcomes for low-income kids, but they end up moving away. And then a new set of people move in, and again, they create good outcomes for that new cohort of people. So there's something about those places that repeatedly generate good outcomes, and I think figuring that out would be extremely interesting. And then the fourth pattern that you see, which I think illustrates the power of having data like this, is, let me draw your eye here to South Dakota and North Dakota, two states with very high levels of upward mobility, among the highest in the US, with the exception of a few very dark red patches, which are by far the lowest upward mobility places in the United States. And those turn out to be the largest Native American reservations in the US, where it's well known that there's a history of chronic intergenerational poverty. And you can see that these data are picking up that phenomenon. Now, it's hard to see the biggest cities in that map, so let me just run through the statistics for some of the biggest metro areas. The reason I started with Salt Lake City is because it's the metro area in the United States with the highest level of absolute upward mobility. And then you have places like Pittsburgh, San Jose, Boston, San Francisco, scattered around the United States with very high rates of upward mobility. If we look at this other statistic that we discussed of the probability of going from the bottom 20% to the top 20%, in these places, those probabilities reach up to around 11 or 12, even 13%. Remember that the number in Canada was around 13%, so you're seeing levels of mobility comparable to that. If you look in contrast at the other end of the spectrum, places like Charlotte, Atlanta, Indianapolis, Detroit, if you're born in the bottom 20%, you have less than a 5% chance of rising to the top 20%. Nearly 1/3 the chance of the highest mobility places. So this variation that we're seeing across areas within the US is actually bigger than the variation across countries. And so one important message that I think just comes out of the simple analysis is you want to think about social mobility as a relatively local phenomenon and not just a broad cross-country issue that we've been focusing on. It's a much more local problem. So that then leads to the next set of results that I'd like to discuss, which is on the causal effects of neighborhoods. So what are we to make of this variation across areas? What's driving this variation? What are the key mechanisms here? That's clearly of great intellectual interest and of great policy interest. So I'm going to divide our analysis of this question into two steps. The first is to ask whether that variation across areas is due to differences in the people living in those areas or due to differences in something about those places. Okay, so what I mean is it that the people who live in Salt Lake City are different from the people who live in Charlotte? At some level, of course they are. There are different sets of people living in these places. But what we really want to know is if we randomly dropped a family in Salt Lake City versus in Charlotte, would we actually see that they have different outcomes if they grow up in these different areas? So in that sense, do places actually have a causal effect? Do neighborhoods matter? Second, if we find that places do have causal effects, and that's what I'm going to try to convince you of, then it becomes very interesting to understand what are the characteristics of the places that generate high levels of mobility. What is it that Salt Lake City is doing that is generating such a high level of mobility? So in the project we're currently working on, which I'm going to present some preliminary results from, we are going to tackle the first question here on this slide by using people who move across areas. So naturally, we don't have the power to run that randomized experiment of randomly allocating families to different areas. So instead, we're going to use a quasi-experimental approximation to that experiment by using people who move across different commuting zones in our data. And so in the next set of results I'm going to show you, we're going to focus on a subset of 3 million families with kids who move across CZs in our sample. Now, to introduce this analysis of neighborhood effects, based on prior work in economics, as I was mentioning at the beginning, should have been that neighborhoods actually don't have very much effect on children's outcomes. So the moving to opportunity experiment, other work done in Canada by Phil Oriopoulos and a number of other studies have found that when you try to move children from lower income areas to higher income areas, you don't actually see significant improvements in their long-term outcomes. So, why is it, given that we actually have an experimental study here, that we think neighborhoods might actually matter and that we get a different result at the end of the day? So the key point is that prior work defines neighborhood quality on the basis of certain observed characteristics. For example, the moving to opportunity experiment moved kids to areas with lower poverty rates. That was the explicit goal of this experiment. Now, in fact, as I'll show you later, we don't find any correlation between mean incomes in an area and levels of upward mobility. So if you think about a place, it's not just defined by the mean income of the people living there, it's defined by a vector of different characteristics, which includes the level of poverty, but also maybe the quality of schools, the types of families, numerous other things about the environment, and so forth. So the moving to opportunity experiment in particular, it's been shown in subsequent work, did not actually significantly change the quality of schools that children were attending. So we moved kids to better neighborhoods on one dimension, but we didn't move them to better neighborhoods on another dimension that might matter, like the quality of education. And so you can see why it's quite possible that maybe neighborhoods actually do matter, but we just haven't focused on the right characteristics of neighborhoods. So what we're going to do here instead is to analyze essentially an outcome-based measure of neighborhood quality. We're not going to try to identify which the good neighborhoods are and which neighborhoods are not so good on the basis of observable characteristics. We're going to say, when we look in the data, we see that in certain places like Salt Lake City, kids seem to do very well in terms of upward mobility, and I'm going to call that a high-quality neighborhood on the basis of outcomes. You can think of this as the value added of the neighborhood. This is analogous to the value added literature on teachers, where we evaluate teachers on the basis of their actual outcomes on kids and not based on characteristics like their experience or other observable measures. So in particular, we're going to define neighborhood quality based on exactly the absolute mobility measures that I've been stressing. We're going to define it based on the expected rank of the children. So we're going to say, given the prior residents who lived in each place, at your percentile of the income distribution, what was the predicted outcome for children? And we're going to call better quality neighborhoods places that produced better outcomes for previous children who were living there. So it's an outcome-based definition, and importantly, that outcome-based definition is going to capture all of these potential factors that might contribute to neighborhood quality. So if it's better schools or it's less crime or things like that, all of those are going to be captured in this outcome-based measure, right? So the limitation is we're not going to be able to tell you what it is about neighborhoods that matters, but this is going to be a powerful way to analyze whether neighborhoods matter at all, which I see as kind of the starting point in this analysis. Okay, so how are we going to use these value-added measures to assess the causal impacts of neighborhoods? So this is going to be tricky because we need to control for all the other factors that might affect children's outcomes and isolate the causal effect of just living in a different place. If you imagine here in Spain, what is the impact of growing up in Barcelona versus Madrid? You want to have everything else fixed and ask, what is the effect of moving a child from place A to place B? Okay, so let me describe to you a variety of different approaches we take, and I'm going to start with a very basic time of exposure design, which is our basic method of analysis. So think about the following. Let's take two children with the same parent income rank P. That means they come from the same type of family in terms of, they're at, say, the 25th percentile of the income distribution, their parents. And they start out in the same initial location, say Dallas, which turns out to be in the middle of the upward mobility distribution in the United States. Now these parents, they move to two different areas in a certain year. Let's say in the year 2000, one of them moves to Charlotte, a very low mobility area, and one of them moves to San Jose, a very high mobility area. What we do is we construct expected child ranks, call them D1 of P and D2 of P, based on the prior residents, the previous people living in San Jose and Charlotte in the same birth cohort. And then we're going to compare the difference in the children's actual rank outcomes for these two children who moved with the difference in predicted outcomes based on the prior residents. So we're basically going to ask, if you move with a child who's relatively young to a place where other kids are doing well, does your own child do better than a family that moved to a place where the outcomes of previous children were not so good? Now, just a little bit of technical detail to explain how we actually do this. Formally, what we're doing is we're regressing the child rank in 2011-12 on the change in the cohort-specific predicted rank between the origin and the destination CZ. So, for example, between San Jose and Dallas. And then we're going to include origin CZ by parent income rank fixed effects. So we're basically comparing two people who start out in the same place at the same percentile of the income distribution, and then they're going to different places, and we're going to ask, do their outcomes vary as we'd expect? And then we're going to do this analysis separately by the age of the child when the parents move in order to see whether the time of exposure to a better area affects a child's outcome. So let me start with the simplest depiction of the results shown in this graph here, which is constructed as follows. Let me first explain what the axes are. So the y-axis is the actual child rank. So what is the actual outcome we see for the child who's moving? And then the x-axis is the predicted difference. So imagine a set of families, to make this concrete, that start out, let's say, in Dallas, here at the middle of the upward mobility distribution. And then these families over here on the right side of the chart, they're moving to places like San Jose, which generate very good outcomes for kids. And these families over here on the left, they generate relatively bad outcomes for kids compared to the places like Dallas, okay? And what we're plotting is the average observed ranks of the families that move relative to the predicted ranks based on the prior residents. And in this graph here, we're using a set of families who move with their children before their children turned 13. So when their children were relatively young. And essentially what you see, to be precise, the way this is constructed is, again, it's a binned scatter plot. We're dividing the x-axis into 20 equal-sized bins and plotting the mean child rank within each of those bins. So you can non-parametrically see the relationship between kids' actual outcomes and predicted outcomes. And so, behind this figure are the millions of data points that are underlying this analysis. And what you can see is that there's a very strong upward sloping relationship, right? So to put it verbally, the families who move from Dallas to San Jose, when we look at their kids' outcomes when they're 30 years old, they are actually doing much better than the families who moved from Dallas to Charlotte. Okay, so this was for a set of families who moved when their kids were relatively young. And the slope here on this graph is 0.54, meaning if you move to a place where the prior kids were doing 1 unit better, your own children do about 0.5 units better on average. Now you can imagine estimating that slope separately by the age of the child when you move. You can repeat this analysis for parents who move when the kids are 10 years old, 11 years old, 12 years old, etc. And what you get is this graph here. So this plots the slopes of that relationship that I showed you on the previous slide by the age of the child when the parents moved. And so the first thing you see here is that it looks like there's a remarkably linear dosage effect. It's like kind of a dose-dependent relationship where if you move to an area, a better area when your child is young, your child does much better, right? So the way to interpret the units on the y-axis here is if you move to a 1 unit better area, how much better does your child do? And so if you move when the child is 6 years old, you get 0.6 of the effect, and then the effect keeps declining, and as the child is exposed for less and less time to the better environment, you absorb less of that place's effect. Now, once the child turns around 20 years old, hopefully when you move from city A to city B, your child is no longer living with you at that point and has moved out of the house. And so this here on the right side of age 20 can be thought of as essentially a placebo test where you've got a set of parents who are moving from Dallas to San Jose. Well, if the child is already 25 years old and is living somewhere else and is working, that should be totally irrelevant for the child's outcome. And in fact, you see, the slope doesn't go to 0, but it becomes very small and the slope of the relationship changes completely where you no longer see this dosage effect. So 2 things to take away from this graph. The first is that this initial cut at the data makes it look like, yes, if I take a family and put them in a better area when their kids are relatively young, their kids do better on average. And second, this is actually quite important for the current policy debate, it looks like every extra year that you spend in a better place, no matter what age, helps you. It's not just the earliest years that matter, which is actually a very important policy debate currently in the United States. Do we need to invest all of our effort in the first 3 years or first 5 years of a child's life? Are outcomes kind of determined by that point? That absolutely does not look consistent with this graph here, where every extra year, be it at age 5, 10, or 15 in a better environment, seems to help the child. It basically looks like a linear effect, right? Okay, now there are 2, you can't quite conclude from what I showed you there, I think, if you're a skeptic, as we should be, that places matter from the analysis that I showed you. And there are basically 2 assumptions that I'm making in going from the evidence that I just showed you to the conclusion that places have causal effects. And they relate to 2 potential concerns you might have about the identification strategy here. The first is selection. So you might think it's very intuitive that parents who move to good areas when their child is young might be those who maybe have higher ability children, or parents who are on top of things and have kind of figured out that I really care about my child's outcomes, I'm investing a lot in my child's outcomes, and I figured out that Charlotte is not a good place, my kid is not doing well here, so I'm going to try to move to a different area. Now, if you have that type of sorting effect, you can get the pattern that I've shown you in this graph here, where the parents who are moving when their children are really young are really motivated parents, and so their kids would have done well no matter what, and then the parents who are moving here are just, their kids would not have done as well even if they hadn't moved. So that would be potentially spuriously generating this pattern, even if places don't have a causal effect. So that's one concern. A second concern is that other things might change when you move. So when you move to a better area, it's very intuitive to think that maybe you also got a better job at the same time, or things became better in the home in some other way. And maybe it's the family environment that actually matters and not the place. So if you had just gotten a better job and stayed in Charlotte, maybe your child would have done just as well. Now it so happens that you got a better job when you moved to Salt Lake City. And so what we're calling a Salt Lake City place effect, maybe that's just the effect of the family and the better job. Okay, so both of these I think are serious potential concerns with the result that I just showed you. So we are going to now address these 2 issues using 2 supplementary designs, which I think illustrate especially well the power of big data and the quasi-experimental approaches you can take to really get at causal effects and try to understand mechanisms in terms of what matters. So what I'm going to do is first show you results from sibling comparisons, so compare the outcomes of 2 kids within the same family, and then I'm going to show you some results on gender comparisons, which I think address these 2 issues. So in order to account for selection, we're going to start by studying within family cross-sibling comparison. So here again, I want you to think about taking a family that moves from Dallas to San Jose, but this time with multiple kids. So let's say 2 daughters. And essentially, I want to ask whether the difference in siblings' outcomes is larger when the age gap between them is larger. So the idea is if I move with a 10-year-old and a 14-year-old, the 10-year-old gets an additional 4 years of exposure to the better environment. If I move with a 7-year-old and a 14-year-old, the 7-year-old gets 7 years of additional exposure, right? So by exploiting the gap in ages between siblings, you get variation in the time of exposure to the better area. And by studying so what we then do is track the siblings forward and ask whether the child who was more exposed to the better area, for instance, the 10-year-old instead of the 14-year-old, does that child earn more as an adult? So by comparing sibling outcomes, you're essentially netting out a family fixed effect, and you're exploiting this age gap within families, which directly gets at that sorting issue, right? Because you're differencing out the common component across these siblings. Okay, and so I'm going to skip the detail here and just show you the graph. I was actually amazed that this actually works in the data. This plots here the impact of moving to a better area, impact of moving to a 1-unit better CZ, on the difference in siblings' ranks. So we're taking the difference in ranks between the sibling who was more exposed to the better area and the sibling who was older and had less exposure. And on the x-axis is the age gap between the siblings. So these children here are 1 year apart. So the younger kid has had an extra 1 year of exposure relative to the older kid. And these kids on the far right here, there's an 8-year gap between them. And so one of the children has been exposed to Salt Lake City for 8 extra years relative to the older child. And so what you can see is that there's a bigger difference in sibling outcomes when there's a bigger age gap between them, when families move to better areas. So that, I think, is very hard to explain by a sorting effect, because why would you have differential effects across your children based on how long they've lived in an area? That really looks like, it seems like the causal effect of the place. Let me show you one final set of results on this, which really starting to convince me that it really looks like neighborhoods matter. So in order to account for this other concern of omitted variables, the fact that the parent might be getting a better job, we're going to exploit variation in place effects by gender. So it turns out that you can construct separate predictions of the expected income rank, conditional on parent income, as I've been doing, separately for boys and girls. And it turns out that it's not identical which places are good for boys and which places are good for girls. It's very highly correlated. The correlation is 0.9, but that 0.1 remaining unexplained difference between the two allows us to identify some places that are better for boys and some places that are better for girls. And basically the pattern you seem to see, which is consistent with intuition from prior literature, is that places with very concentrated poverty tend to be particularly bad for boys. And that's because there are very high rates of urban crime in those areas, and that primarily affects boys rather than girls. And second, places with more single-parent households, where you typically don't have a father in the household, they tend to be worse for boys, and that's consistent with some recent work that David Otter at MIT and others are doing, which suggests that being in a 2-parent household, that is having a father figure around, is more important for boys than for girls. Okay, so because of variations like this, it turns out that some places are a little bit better for boys and some places are a little bit better for girls, and we're going to exploit that variation for identification. So what we're going to do now is compare the impact of moving to an area that's better for children of the same gender versus another gender. So coming back to my running example, take the family that moves from Dallas to San Jose. Let's say San Jose is particularly good for girls. If they have a daughter, do we see a considerable improvement in the daughter's outcome? If they have a son, do we see less of an improvement? So essentially what we're going to do is regress a child's outcomes on the change in predicted ranks, both for their own gender and for the other gender. And if places have a causal effect, you would expect that the own gender prediction should matter for the, if the prediction for boys should matter for boys, and the predicted outcomes for girls should not matter for boys once you control for the prediction for the same gender. In contrast, the omitted variables sorting type of explanations, it's not at all intuitive why you would expect them to generate these types of differential patterns by gender. And so here's that final result. This is coming back to the basic scatter plot that I showed you. This is taking children who moved when they were less than 13 years old and plotting the actual difference in the child rank versus the predicted difference. This time, for the first series I'm showing you here, based on your own gender. So think of this as, suppose we're focusing on boys. What is the impact of living in an area that's very good for boys versus very bad for boys? You can see there's a very clear relationship. And now compare that with the impact of living in an area that's very good for girls versus not very good for girls. Controlling for the boy effect, it is irrelevant essentially whether you're in an area that's good for girls or not. That really looks to me like it's a causal effect of place rather than some other thing that's generating these differential impacts by gender. So that's the main set of results I wanted to show you, and I think what that shows you up to this point is that places really appear to matter. So contrary to what you might have thought from some of the prior neighborhood effects literature, it seems to me like neighborhoods really matter for children's outcomes and for social mobility. So the last thing I'd like to do is just in the remaining couple of minutes, just present some preliminary evidence on what makes some places generate better outcomes than others. What is it that Salt Lake City is doing that's making kids, if we randomly drop a child in Salt Lake City, it seems like they're going to do better than if we randomly drop a child in Charlotte? Why is that? So that's a very difficult question to answer. And as a first step, we're going to correlate differences in mobility with observable factors. And essentially the way I think about this analysis is that it's a search for stylized facts that might eventually help us find the causal mechanisms. So the initial, when we were investigating this, initial clues into potential mechanisms came from the timing of the effect. What we see in the data is that the spatial variation in inequality emerges at very early ages, and in particular, well before children start to work. So one set of explanations you might have had in mind is that maybe it's about differences in the types of jobs that are available in some places that provide kind of a ladder to move up in the income distribution relative to other places. What the patterns we're seeing in the data suggest that that's not likely to be the primary source of the difference because the differences emerge well before children start to work. So let me show you that evidence as follows. Returning for a moment to the national level first, and this chart here plots college attendance rates versus parent income ranks. So the same x-axis as we've had in many of the prior charts, but now on the y-axis is college attendance measured around age 20. And you can see that there's a remarkably strong relationship between college attendance in the US and parent income. If you're from a very high income family, almost 100% chance you go to college. At the bottom of the distribution, only a 25% chance you go to college. Now we estimate the slope of that line, again, that gap in college attendance outcomes, the disparity between low and high incomes, in every area of the US. And we put that slope again on a heat map where here, lighter colored areas are areas with less of a disparity in college attendance rates. And broadly, what I want you to see in this map is that it looks pretty similar to the maps that I was showing before, right? The South has much larger gaps in college attendance rates than other parts of the country and so on. The correlation with the baseline measures of mobility is something like 0.7. So that suggests that a lot of the gap between low income and high income kids across areas has emerged by the time they're 18 or 19 years old. You can go a little bit further than that, look at another outcome, teenage birth rates. This repeats the national analysis plotting the probability, the fraction of women who have children while they're teenagers, and actually the magnitudes here are quite striking. If you're from a family in the bottom 1% of the income distribution, 30% of those girls have kids while they're teenagers, and that drops to nearly 0 for kids from high income families. Again, we estimate that slope by area, put it on the map. Areas that are lighter colored have flatter slopes, that is lower teenage birth rates for low income kids. And once again, pattern's not identical, but it looks pretty broadly similar to what we started out with. So what that suggests is by age 15, 16, 17, you're starting to see these gaps in outcomes emerge. So that early emergence of gradients points to factors that affect children while they're growing up. And so the final result that I'm going to show you is ask, what are those factors that seem to matter? We correlate these proxies for various broad factors with the variation in upward mobility across areas. And there's a really detailed analysis of this in the first paper that I mentioned. I'm going to be very brief here in the interest of time and just give you the highlights. So in this chart here, we're plotting on the x-axis the correlation of our measure of absolute upward mobility across those 740 areas with various proxies. The dots show you the point estimate of the correlation. In parentheses, you see the sign of the correlation, and then the lines show you the 95% confidence interval. And we look at various categories. The first category I start with here is segregation. And one of the first important factors we find is areas with higher levels of racial and income segregation, where low-income people are not living near high-income people. They tend to have much lower rates of upward mobility. So the cities that have really high rates of upward mobility tend to be denser cities that are more integrated. Just from a correlational perspective, that's a fact you see in the data. Now, I don't have time to talk about detail, but we look at numerous other factors. And let me just highlight the 5 most significant ones. I mentioned segregation. A second very important correlate is the degree of income inequality in an area. Places with more inequality within a generation also have less social mobility. I think this is really important if it's a causal effect, because it suggests we should be concerned about inequality, not per se just for itself. Even if you're not concerned about that, you should be concerned about it from a social mobility perspective. A third important factor is the quality of education, as proxied for by various measures. K through 12 primary education really seems to have very strong correlations. And then the 2 final factors, which actually link nicely with the theme of this conference and Tony's work on social issues, 2 of the strongest correlates are measures of social capital and family structure, kind of the social cohesiveness in an area, the degree of religiosity, the degree to which people help each other, sort of, maybe you might think of it as networks in an area. And another, version of that, another very important correlate, actually the single strongest correlate in the data, is the fraction of single parents in an area. So areas with more single parent families have much lower rates of upward mobility. Again, suggesting that something about family social factors maybe matters, or it's picking up something else that matters. So to conclude, there's substantial variation across small geographic areas in upward income mobility in the United States. The preliminary analysis we've done from people who move across areas suggests that this variation is largely driven by the causal effects of neighborhoods. The estimates suggest that these CZ level neighborhood effects are roughly 1/3 as large as the parent-child income correlation that we started out with. So that's pretty big neighborhood effects. And we're defining neighborhoods in a very broad way, right? We're talking about, say, like the whole Barcelona metro area. My guess is if you were to zoom in much more finely, you'd find that neighborhoods matter even more. And so the main lesson I take away from this is that intergenerational mobility is shaped at least partly by environment and therefore may be manipulable by policy, which I think is very encouraging. The next step in this type of research is to use this type of cross-area variation to learn more about the determinants of upward mobility. What is it that these high upward mobility areas are doing right, and how can we replicate that in other places? And to achieve that goal, here we turn to all of you, and we're hoping to draw on the insights of other researchers. We've posted all of the statistics that I've shown you here, mobility rates by county for the United States, by birth cohort, which will allow people to study local policy changes and figure out what exactly we can do to improve social mobility in the US and throughout the world. Thank you very much. Yes. Yeah. Oh, yeah.
So is it on?
Yes.
Okay. The results that you did to check whether the effects are really causal, I guess the extreme skeptic might still say that there's something mysterious about what makes people move. That I know that I'm a Salt Lake City person, and so I go there, and we are the ones on whom the effects really of Salt Lake City really operate. But if you just drop a random person, it wouldn't operate.
Yeah, so there are 2 potential issues there. So one is, what you're talking about is basically local average treatment effect versus a treatment effect for the average person in the population. So we are estimating a treatment effect only for the people who chose to move. That's absolutely right. And we're finding that you end up looking very much like the people there. So it's possible that if you took somebody, and I think this is probably right, if you take somebody who's totally attached to some other neighborhood and who would do disastrously badly if they left that area, you might not see similar gains if they move to a place like Salt Lake City. So we're looking at people who are willing to move, who are on the margin of moving. I would say that's arguably the policy relevant. I mean, depends upon exactly what policies you're talking about. So if you're talking about policies that might encourage people to move to better areas or change things on the margin, it's possible that that's the policy relevant effect. If, on the other hand, you're talking about changing policies in a given area, you're right, you want to get closer to the average treatment effect. It's not totally obvious from what I've shown you. At the least, I think this suggests that neighborhoods do seem to matter to some extent. The other thing I should say is, we certainly don't think moves are random. It's clear that the types of people who are moving are different from the people who are not moving. They they look different in various ways. But importantly, we think that heterogeneity is not correlated very strongly with the age of the child at which people are moving. And so that's what still allows us to isolate the causal effect of the place.
Is it on? Okay. I was interested in all of these Iowa places that seem to have like such a high mobility. Is this controlling for purchasing power parity? Mm-hmm. Because if you're very low income and you move to New York, you might still be poor, but your income is higher. Yeah,
very good question. So what we do to address that is we compute cost of living adjusted measures of income. So we use local cost of living indices and deflate the child's income by the local price index where they live as adults, and similarly for the parents, replicate the analysis, and you get very similar patterns, correlation of more than 0.9. And the reason fundamentally is that if children do not move to a very different area, then a cost of living adjustment's not going to matter, right? Because it's going to affect both the child's rank and the parent's rank in the income distribution. And because we're looking at mobility, which is the difference between the child and the parent's income rank in a sense, that ends up being essentially invariant to the cost of living adjustment. But if you have your example where you're moving from a low-cost area to a high-cost area, then you could potentially have a significant effect. Turns out that while there are such movers, they're not common enough to substantially change patterns. People do move, but they move to sort of nearby areas with levels of cost of living that are not super different from where they started. So empirically, it just turns out not to be a huge effect. All right, very good. Yeah.
Okay, thank you so much, Professor Calvó. That was, I think, very inspiring and almost overwhelming to think of all the things that we can learn and do, right? We have a cup of cava, and thank you all for your attendance at the exit. Okay, thanks.